Okay, so to continue with the scenario analysis, to continue from the previous video, assuming that the cash flows are independent, each year's cash flow are independent, we have the mean present value of 14,817 and standard deviation of 9,714 Newton. So you can see that this is the mean, and the probability distribution curve actually extends around 97 point some percent of the probability distribution curve is within minus 3 standard deviation to plus 3 standard deviation, where sigma is actually standard deviation. So that means there is 97 point something percent probability that the actual values will lie within this probability distribution curve. So now if we try to find out the Newton value of the present worth at minus 3 standard deviation, then we have 14,325. At a point of plus 3 standard deviation, we have 43,959 Newton in terms of Newton. This plus 3 sigma and minus 3 sigma, 6 sigma, minus 6 sigma, plus 6 sigma, these are the Z values. But these are in terms of Newton values. Okay, we have converted minus 3 sigma in terms of the Newton value. Corresponding to minus 3 sigma, what is the Newton value? That is minus 14,325 Newton, minus Newton 14,325. What is the Newton value corresponding to plus 3 sigma? That is Newton 43,959. So if you try to understand, I said that there is 97 point something percent of the actual values actually happening should be, which is supposed to be within minus 3 sigma to plus 3 sigma. So assuming that the cash flows, each year's cash flow are independent, then with the worst case scenario, we found that the pessimistic estimate of the net present worth is equal to minus 42,755, and uh, optimistic uh, using optimistic estimate, the net present value was found out to be 87,230 Newton. So these Newton values, if you try to express in terms of the standard deviation, it is at a point of minus 5.26 sigma, which is way beyond minus 3 sigma. That means the probability of having a net present worth of 42,755 is almost impossible, because I said that if the actual values lie within minus 3 sigma to plus 3 sigma, then we have 97 point something percent chances of actually occurring. But with this uh, case where the net present worth is minus 42,755 Newton, this is way beyond this lower bound, which is minus 3 sigma. So the probability of this probability of the net present worth of 42,755 is almost equal to 0. So there is, the probability is almost 0, or we can say that this is not possible. And if we also see the best case scenario, it is also way beyond plus 3 sigma. So we can also rule out the probability of getting a net present worth of 87,230 Newton. If the net present worth in the best case scenario, assuming independent cash flow were 43,959, then we could have said that it is possible. But in this case, this net present worth for worst case and best case scenario are both way beyond the lower and upper limit. We can rule out the probability of these two present worths, net present worths, actually happening. Okay, so now moving on further. So far we assumed that the cash flows, each year's cash flows are independent. So when we used this formula to calculate the expected or mean present worth for the project, then it was as if the each year's cash flow were independent, because we simply took because these formulas actually uh, is nothing but the summation of the present worth of each year's cash flow. But in reality, the cash flows are not independent. Each year's cash flow is not independent of other year in reality. And that aspect is taken care when we actually calculate the mean or expected present worth using the beta probability distribution function. In the earlier case, the expected present worth was calculated using this formula, which is essentially nothing but a summation of the summation of each year's present worth. Except that the expected cash flow in each year, we have taken it as a range from worst case to best case. But using this formula, it doesn't take care of the relationship between one year to other year, the cash flow between one year and other year. Whereas when we calculate the expected present worth using this formula, and actually we are using the present worth of worst case, most likely and best case scenario, and calculate the mean, then we are actually taking care of the effect of each year's cash flow on the other. So now we are actually relating the relationship between three present words, three net present words: worst case, most likely, and best case. We are calculating the mean using these three net present words, and in doing so, then we are actually taking care of the relationship uh, both across and along each case. Because this 42,755 was calculated using these values, which is the worst case scenario, most likely scenario, and best case scenario, and the net present worth of each scenario is then uh, related in terms of this function. We are actually taking care of the relationship across the worst case, most likely, best case, and also along worst case, most likely case, and best case. The thing is that unlike in the earlier case, the expected or the mean present worth was simply a summation of the present worth of each year's uh, present worth. Here, the present worth of each case are related in terms of this function. So the interrelationship across and along each of these cases are actually aggregated in this formula, and that is taken care in case of scenario analysis. So that is why we are saying that unlike in the case of sensitivity analysis, the dependencies within the cash flows in each year and across the cash flows in each year are dependent, and its effects are taken care because of because we are actually calculating the mean present worth or expected present worth using this function or formula. So using that, we have the expected or mean present worth equal to 14,817, which is the same thing, of course, but the variance is 21,664 square, and the standard deviation is under root of this one, so which is 21,664. So using these two uh, information, the mean and standard deviation, we can assess the probability of these present worth in each case, worst case, most likely, and best case. Okay, so in this case the mean is same, which is 14,817, but in this case the 42,755 is corresponding, this 42,755 corresponds to 2.66 sigma, which is inside this minus 3 sigma. Actually this is minus 2.66 sigma, which is inside this minus 3 sigma. So this value of the net present worth 42,755 from the point of view of dependent cash flow, we cannot rule out that this minus 42,755 Newton will not happen, because it is within this bound minus 3 sigma to plus 3 sigma. And on the for the best case best case scenario, the net present worth of 87,230 corresponding to this net present worth in terms of the Z value, it is 3.34 sigma, which is beyond plus 3 sigma. So this net present worth of the best case scenario we can actually reject and say that this is not possible because it is outside plus 3 sigma, whereas the net present worth of the project falling and taking on the value of minus 42,755 Newton, we cannot rule out. Okay, so this 50,175 Newton corresponds to this minus 3 sigma, and this 79,809 corresponds to plus 3 sigma. Okay, so I will stop here. Thank you.